So we're looking at a trigonometric kinematics question today. And when it comes to kinematics, when you remember, we're going to still follow the same rules that we do with normal kinematics, especially in trigonometry as well, where we have your position vector identified as x of t, your velocity vector, the first derivative, and the acceleration vector, the second derivative. Other things that we need to remember are such things as when the first derivative is equal to 0, we're changing direction, we're at rest. And if the speed, if the signs of your velocity and acceleration vectors or signs are equal, it's increasing. If they're opposite, decreasing. The difference that we do when it comes to trigonometry is we use the unit circle for our substitution values. So let's get into this question we've got up here. We've got a particle moves in a straight line along the x-axis with position given by x of t, 3 plus sine 2t centimeters after t seconds. Okay? We're asked to find the initial position, velocity, and acceleration of the particle. So we need to work out what x of t, x dash of t, and x double dash of t is first. So if we look at part A, we know we've got x of t is equal to 3 plus sine 2t, okay, given by information here. So therefore, we now need to work out what our first derivative is, and this here should give me 2 cos 2t centimeters per second, and then our second derivative should then be negative 4 sine 2t in terms of acceleration. So we've now got our first, second, and our position, our velocity, and our acceleration. We now can start replacing all our t's with 0 to get our results. So if x of 0 for the first one, we end up just getting sine 2 times 0. Now, if we look at the unit circle here, and we bring this up on this side, you can use your calculator to get this answer. However, some of these questions may say show that the answer results into this. So from what we know about the unit circle, is that we're working with radians here, where if we look at the coordinates, we have, let's my brackets first, we have x is equal to 1, y is equal to 0, x is 0, y is equal to 1, x is negative 1, 0, and then 0, negative 1. Now, another thing to remember is that sine theta is all equal to the y coordinates, and cos theta is equal to the x. So we're looking at y. So where is sine equal to 0? Well, it's just this point here. What is our result? So at 0, we get 0 centimeters. At x dash of 0, we have 2 cos 2 times 0. Well, we know that cos at 0 is equal to 1 because it equates to 1. So for instance, if this here was 2, let's say pi on 2, we look at the x coordinate for pi on 2 here, which is 0. So I'd replace the cos with 0. But in this case here, we've got a 0, so therefore we've got 2 times 1, because it's 1 here. So your final answer here is 2 centimeters per second. And then for the last one, same kind of calculations. We're going to be at the same position. So 4 sine 2, 0. Again, look for the radian of 0. What is the coordinate in respect to either sine or cosine? Sine being y. We'll look at the y coordinate, which is 0. Okay, so therefore we get 4 times 0, which equals 0 centimeters per second. So if we were going to interpret this, the questions are asking us, what we would say is that the plus 3. is equal to 3 here. Okay, well, I missed that 3 there. We would say that your particle is 3 centimeters to the right of the origin, moving at 2 centimeters to the right, and with no acceleration. Okay, so this is what we would do for our first part of our question. Let's have a look at the second part of the question. And the second part of the question here is asking us, find the times when the particle changes direction. So let's come back up to this. Our particle, when it changed direction, remember, was 2 cos 2t. So we have to equate this here to 0. So if we have x of t is equal to 0, then what we would have here is we'd have 2 cos 2t is equal to 0. And just like we do with normal calculations, we want to find t by itself. So let's divide both sides by 2. So we get cos 2t is still equal to 0. And now we're trying to ask ourselves, where does cos equal 0? So where is x equal to 0 on the unit circle? Well, we know x equals 0 at pi on 2. So we can write 2t is equal to pi on 2. Where else is it equal to 0? At 3 pi on 2. Okay? We still now need to get rid of, so again, that's exactly like we did in that last example where I'm replacing the t with a radian here to give me that result. So if I replaced t with pi on 2 here, pi on 2 would give me the 0. If I replace t with 3 pi on 2, forget about the 2 here, I'd get 0 down here as well. We still need to get rid of this 2, so when we divide by 2, we times by a half. So this here becomes pi on 4 and 3 pi on 4. Now what we need to remember here is, does this fit within the range that we're given? And the range that we're given here is it has to be between 0 and pi. If you left your answer like this, then you would say, you know what, I've only got one answer. But because we have to get rid of this 2 and distribute it through, both these results now fit within that range. We now want to find the times and the direction that it changes. Okay, so we need to find that position as well. So now that we know that we can plug these calculations in, let's now work out what x of 0 is, what x of pi on 4 is, what x of 3 pi on 4 is, and then we'll do it over here so I don't bend down too much, what x of pi would be. Now we know what x equals 0 is because we worked out at the start. That's equal to 3 centimeters. X of pi on 4, well, we're replacing 2t, or replacing the t with pi on 4. So if we had 3 plus sine 2 lots of pi on 4, okay, this here is the same as doing 3 plus sine 2 pi on 4, which is the same as 3 plus sine pi on 2. Okay? So because we got pi on 2 here, where is pi on 2 and what is the equivalent to sine pi on 2? Well, pi on 2 is up here and we're looking for the y coordinate, and the y coordinate equals 1. So therefore, the answer here will be 3 plus 1, which equals 4 centimeters. So at pi on 4 seconds, we're 4 centimeters to the right of the origin now. If we now look at the next part, which was x of 3 pi on 4, again, you could use your calculator and get these answers, but I'm still going to go through the process of how this all works. Okay. We then get 3 plus sine, well then we get 6 pi on 4, which is the same as sine We can simplify this out, divided by 2, so we get 3 pi on 2. Okay, so if we get 3 pi on 2 here, let's find out what is the y equivalent of 3 pi on 2? It is -1. So therefore, what we get here is we get 3 minus 1, which equals 2 centimeters. And then the last one would be x of pi is equal to 3 plus sine 2 lots of pi, okay? Which is the same as 3 plus 0, which is equal to 3 centimeters. So, 3, 2 pi, are we doing that correct? Let me check. Pi is over here. So that gives me, sorry, not 0. It does, yep. Okay, so we get the 3 centimeters. Alright. Let's now have a look at the last part of this question. So we've now worked out the times and directions. So at 0, it's 3 centimeters to the right. At pi on 4 seconds, it's 4 centimeters. It's at the 4 centimeter mark. At 3 pi on 4, it's at 2 centimeters. And at pi, it's at 3 centimeters. The last question, which we'll do just up here, is asking us, find the total distance travelled by the particle in the first pi seconds. So if we did a nice line diagram here, we know that this is where the origin lies. Our particle, remember, starts at 3 seconds. So we can put 3 here and say that's where our particle's starting. It changes direction at pi on 4. So this is where we have t is equal to 0. At pi on 4, it's 4 seconds. So it's travelled along here by 1 second, and it changes direction. So here at t on pi on 4, it's travelled for 1 centimetre. It then changes direction until it gets all the way back to 2, because that's where it changes direction again. So from 4 to 2, it's travelled 2 centimetres. So in this case here, we've got t is equal to 3 pi on 4, and then because we're going all the way up to pi, we come back up to 3, and we've travelled 1 more centimetre. So the total distance travelled here would be 1 plus 2 plus 1, which equals 4 centimetres. So this here is the distance travelled. If I wanted to work out how far I've been displaced, well, I haven't been displaced at all because I've started from where I've finished. So when we're looking at trigonometric questions, especially with kinematics, we've got to remember we're using the unit circle to help us solve these calculations. Alright, good luck.